Hello, everybody. My name is Qin Yang. I'm a researcher specialized in robotics and AI. Today, I will represent my paper, A Hierarchy Game Theoretic Decision Making for Cooperative Multi-Agent System under the presence of the adversary agents. And I will separate 5 parts to introduce this paper. First, let us have some background knowledge about this research. So multi-agent system is pretty common in our world, even in the universe. In natural systems such as the cell, neuron, animal, even in the human societies, those agents they are organized their behaviors, cooperate with each other, uh, forming different kind of the formations, structures, represent different kind of the function properties to adapt the various environment. In artificial systems, like the robot agents, such as the self-driving cars, multi-robot systems, and software entity, they are characterized by apparently complex behavior that emerging as a result of the often nonlinear spiritual tempo interactions among large number of the components at different level of organizations. So, like the Woodbridge Michael described, the multi-agents consist of a number of agents which interact with one another. In most general case, the agents will be acting on behalf of users with different goals and motivations. To successfully interact, they will require the ability to cooperate, coordinate, negotiate with each other, much as the people do. So in this research area, we have a very important concept is what is the strategy. So the strategy describes the general plan of the agents achieving short-term or long-term goals and uncertainty. It involves setting sub-goals and priorities, determining action sequence to fulfill the task, and mobilizing resources to execute the actions. The other is the essentials of the intelligence. So actually, even we discussed the intelligence a long time, but currently we still do not have a specific, a clean definition about the intelligence. But from my research perspective, the intelligence can be regarded as the global adaptive behavior caused by individuals, agents, interaction, and cooperation, executing a diverse strategy to satisfy their various needs or the entire system utility in specific scenario. So the other important way to review the domain space in MRS is by understanding the type of the interaction among those agents. The common forms of the interaction in multi-agent system, especially the multi-robot system, can be classified four direction: collaborative, collaborative, and coordinative. They are based on the awareness of the agents and the type of the goals for the agents. And the second part, we will briefly review the background knowledge in this research. First is the agent's motivations. So actually, the agent's motivation can be described as their inner value or needs. The agent has the plasticity to encode the feedback received from its interactive environment continuously, and the encoding of the experience should facilitate the emergence of the adaptive behavior. The right picture, I just give you guys a very generally agents intrusive the motivation models. As you can see in this module, we have an intrusive the motivation components and the behavior components. So first, the agent through the sensors get the information from the environment. Then, based on their inner value or needs, they will decide what kind of the decision they will making, and through the actuators, they will execute the specific actions. sequence. The other pretty important concept is the needs-driven behaviors. Since the needs is described the necessary for a self-organizing system to survive and evolve, so it arrived an agent to action toward a goal and giving purpose and direction to behaviors. So the agents need to satisfy a certain amount of the needs at a current level as a condition to arrive the next stage to upgrade and evolutions. So the very classical model to describe the human agents, the motivation from the needs is the Maslow's hierarchy of the needs. They divide the humans the needs as 5 kinds of level, like the lowest level psychology needs, and the safety needs, the belonging needs, the esteem needs, and the highest level self-actualization needs. And the domain approach to describe the agent needs is use the utility theory, and it serves as a unified concept in a value system to describe the capacity of the actions, behavior, and strategy to satisfy agents' desire and needs in their decision makings. And the right picture, I just give you guys the big picture about the multi-object, multi-agent decision-making settings. And based on the above the discussions, we want to modify, especially module the artificial agents' motivation and needs in their interaction. So we defined the agent needs hierarchies inspired by the Maslow's hierarchy of human needs. As you can see in the right pictures, in order to guarantee the safety when the artificial agents interact with others, the partner, especially the humans, we switch the safety needs in the lowest level to guarantee the safety when they interact with other agents. And the last very important concept is the game theory. Since game theory is the discussed strategy of the about the agents, it provides a theoretical framework to conceive the social situation among the competitive players. When we design a game, first we need to design the specific utility function for the agents. Then we'll consider what kind of the interactions in those games and design the specific scenario and agents in the games. Next part, we will briefly discuss the motivation and challenge. Since currently we do not have too much approach to help the agents, artificial agents, especially the multi-agents, to represent more complex the strategy and behavior. So in order to build a deeper cooperative relationship among agents and represent more complex the team strategy, we need to develop the scalable, efficient, and effective approach for RAS the cooperative decision making in adversary and dramatically changing environment. And also currently we do not have a domain to help us to analyze the agent's performance from the success probability for achieve the and fulfill the task and with low cost. So we need so it is more realistic and practical for RAS to organize the complex relationship and behaviors, achieving a given task with a higher success probability and low cost in adversary environment. So so this part we will briefly discuss our research contribution, and we have a 4 contribution. First, we introduced a new domain, Explorer domain, and next we proposed a novel approach to organize the complex strategy in MRS, and we demonstrate our approach in simulation and hardware platform Robotarian. First, we propose the Explorer domain, and we represent a game of the Explorer and aliens to analyze the MRS performance by balancing the success probability of achieving tasks and the system cost by organizing involved agents relationships and suitable group strategy in adversary environment. And we formalized this problem in the right pictures. Next, we propose the game theoretical utility tree gas. So I give you guys a very simple example. Suppose in our scenario, when the explorer encounter with the alien, they need to decide the specific purpose, like the attack or defend. Then they will decide the specific target they want to attack or defend. And last, they will decide how to organize their group, like the 1 group, 2 groups, 3 groups. So if we want to determine this strategy in the games, use the original game series, we need to build big games. And in this game, we have a very large strategy space to describe this situation, like the 216 combination in this big games. But we using the gas. First, we can decompose this big game into several small games and organize those small games as a tree structure. And through compute the Nash equivalence in the small games, and we can find a specific trajectory in the gas structures and for the decision in the current situations. And this picture just illustrates the general concept for the gas. Then we demonstrate our method in the proposed Explorer game domain, and we design 2 scenarios. One is an interaction experiment, compare the performance of the Explorer cooperative strategy between gas and Q-mix, the state of smart methods, and information prediction demonstrate the gas with a different predictive model are implemented to estimate the alien's states. And we analyze the gas by simulating various cooperation methods like the non-cooperation, partial cooperation, and full cooperations, and compare with the performance with the state of art method of Q-mix. And this is the demonstration video, and I just quickly go through it. First, we consider the non-cooperation, and this is the partial cooperations. And this is the partial cooperation with the partial communication. And this is the full cooperations, and those agent explorer can organize their behavior through the gas. Yeah. And this consider more complex scenario, the unintentional adversary, the mountains. And the last, we consider a more complex scenario, the unintentional adversary mountains and intentional adversary, the aliens, and also compare with the state of art method, the Q-mix. finally they will achieve the treasures. So this is the evaluation for this experiment. We analyze the explorer average HP cost and the kill of the per aliens explorer lost, and the performance just shows our method gas can have a great performance compared with the state-of-art method and other method. Then we demonstrate our method in the hardware, the real multi-robot platform Battalion in Georgia Tech. And we design three kind of scenario: one explorer, one alien, one explorer, two aliens, four explorer, three aliens. And this is demonstration video. First, we simulated our different scenario, and this is hardware demonstration. One explorer, one adversary, and two adversary, one explorer. And this is the more complex scenario: four explorer, three adversary, and also consider unintentional adversary obstacles. As you can see, the explorer will change their formations, which means the strategy based on different kind of the scenario. And finally, in the gas pouch, they will finally get the destination more efficient compared with other pouch. And this is the evaluation for the hardware demonstrations. As you can see, compared with the other method, our method gas have a great performance. So conclusion, this research we introduced a new network model called game theoretic utility tree gas, mimic the multi-agent decision-making process for corporation working in adversary environments. And we verified the effectiveness of the gas in the proposed explorer domain compared with the state-of-art QMix through simulation and hardware demonstration. And the future work have a lot of the research direction, such as the how to developing of efficient reinforcement learning approach to organizing group behavior and strategy, how to develop a more efficient, effective communication structure, how to build a stable and reliable trust network for cooperative RMS. And more advanced topic is the how to build a framework to let the AI agent work with the human in harmonious. And this is the picture illustrate of the relationship of the utility-oriented paradigms based on agents' needs among the single agent, multi-agent, and human-robot interactions. And as you can see, first the single agent needs to satisfy their individuals' needs and utility. Then they will consider how to cooperate with other agents and group members and certify the group utility. And more advanced, they will consider how to cooperate with the human to achieve the common goal, to certify the humans' needs and adapt humans' behaviors, such as guarantee human safety and make a reliable, stable environment. Okay, this is my paper demonstration. Thank you very much. If you have any question, please contact me through this email. Thank you.